Hi, so we want to try and prove this statement, that if you sum the first n natural numbers, all of them raised to some integer k, the sum of that will be a polynomial in n of degree k plus 1. We know this to be true, for instance, for the first, if we let k equal to 1, we'll have a quadratic polynomial in n. So I'm going to let my induction statement p of n, and I'm going to take this off because I want to rephrase it a little bit. Because instead of showing this for degree 1 and then raising the degree one by one by induction, I want to assume this is true for all degrees but for the first one term, and then show that therefore it's true for all terms, or regardless of the number of terms. So my induction statement will be p of n, the sum of I going from 1 to n of I raised to the power of p equals a polynomial of degree p plus 1, which is therefore I'm going to use a new index, let k go from 0 to p plus 1 of some coefficient a k times n to the power of k. And this is true for all degrees p which are positive integers. And so this is my induction claim, and I want to see, well, if this is true for the n first terms, will it therefore also be true for the n plus 1 first terms? So I have the sum then of I going from 1 to n plus 1 of I to the power of p. But this is obviously the same as the sum of I going from 1 to n of I p plus n plus 1 raised to the power of p. And this, we have a claim to what it is. It's this. So we have the sum of k going from 0 to p plus 1 of a k n k plus, and this will be a polynomial in p of degree, or in n of degree p. We could actually calculate the coefficients using the binomial theorem, but we're not going to actually bother to. I'm going to give these coefficients just a letter and an index. So we have the sum of, running out of indexes, say r going from 0 to p of br n to the power of r, where br includes both the binomial coefficient and, well, there won't be any another from d1 there. But rearranging this, I see that I'm going to have a sum going from k equals 0 to, this only goes to p, this goes to p plus 1 of n to the power of k times ak plus bk. And in order to do this, I should also define b p plus 1 equals 0 to take care of that. Or I could have put the p plus 1 term out of this. But what is this? It's a polynomial in, assume these then, call them something like ck, and you have a polynomial of degree p plus 1 in n with some coefficients. So therefore, Pn, if Pn is true, then this implies that Pn plus 1 is true. So is this true for P1 then? Well, P1 is the sum is basically the first term, so it's IP, it's 1 to the power of p, whatever degree p, and that can obviously be written like this. It's claiming that a p plus 1, AP equals 1, all the others are 0. AP is not equal to 1 equals 0. So therefore it's valid for P1 and it's valid, and it shows the induction statement is valid for the first term of all degrees, and if it's valid for one term, it's valid for the next term, so it's valid for all terms. So we have proven what we wanted to prove.